Topic for the day is expansions. This topic you have studied in class 7 and class 8, and now we are going in class 9. We will develop it further with more complex sums. Let us have a quick look at the various formulae before we come to some typical problems. A plus B the whole square. Square first term, a, that is a square, square second term, that is plus b square. Whenever you square, terms are always positive, like minus 7 the whole square will be 49, okay, positive 49. So a plus b the whole square will be u square first term, that is a square, u square second term, that is plus b square, and then we have first term into second term into 2. First term into second term into 2, that is what, 2ab. So it is not like actually 2ab, it is first term into second term into 2, so that is 2ab, and we are multiplying two terms, both of which are positive, so answer also will be positive. So this will be plus 2ab. Have you understood this formula properly? Because now I will go quick. A minus b the whole square. Square first term, so that is a square. Square second term, so that is plus b square. Then first term into second term into 2. Sign to be adjusted logically. So a into b into 2, so that is 2ab. And positive into negative is negative, so that is minus 2ab. So we have a minus b the whole square as a square plus b square minus 2ab. Third one, we'll take now fractions. So these two are the base formulae. You can easily develop the formula in case there is a fraction. A plus 1 upon a the whole square. Imagine now this is your a, instead of b it is 1 upon a. So what treatment you gave here to a and b, same treatment you apply to a and 1 upon a, and you will get your answer. So let's see a plus 1 upon a the whole square. Square first term, square second term, so it is 1 upon a the whole square, that is 1 upon a into 1 upon a, so it is 1 upon a square. Then first term into second term into 2. First term, so it is not 2ab or something, it is always first term into second term into 2. So it is a into 1 upon a into 2, a into 1 upon a into 2. So that will be how much? 2 only. A and 1 upon a will get cancelled, and positive into positive is positive. So it is plus 2. Fourth one, a minus 1 upon a the whole square. You square first term, square second term, then it is what? First term into second term into 2. So a into 1 upon a into 2. So that is minus 2. Comfortable with this? So these two are actually the base formulae as far as squares are concerned, square of a binomial. Now this is based on this, and formula 4 will be based on formula 2. So don't think that there are too many things to be remembered, no. Okay, you just remember a plus b the whole square, that we have told you how to remember it. Then a minus b the whole square, and then a plus 1 upon a the whole square you have to go on the basis of formula 1, and a minus 1 upon a the whole square you have to go on the basis of formula 2. So comfortable. So first what I will do is I will give you we have given you all the 4 formulae pertaining to squares. Now we will come to cubes. Formula number now 5, a plus b the whole cube. Be careful, it is a plus b the whole cube. This will be a cube plus b cube, a cube plus b cube plus 3ab into a plus b, right? A plus b the whole cube will be a cube plus b cube plus 3ab. So how to remember this? Cube first term, cube the second term, then it is plus 3ab. Plus 3ab means it is not actually plus 3ab really. If this is x and y, then this could be plus 3xy, no? So this is actually 3 into first term into second term. It is 3 into first term into second term. If first term was say 5a, second term was 7b, then it won't be 3ab. It will be 3 into 5a into 7b. Accordingly, things will change. So get that treatment. So plus 3ab into a plus b. So this thing repeats here. So this formula is more useful rather than the opened version of this formula. Okay. So this will be, if you open it up, it will be plus 3a square b plus 3a b square. Now let's come to formula number 6 and the last formula. Okay, because then we have trinomial square, that we will take it later on. Okay. So a minus b the whole cube, that will be a cube minus b cube, a cube minus b cube minus 3ab into a minus b, minus 3ab into a minus b. Okay with this? So these 6 formulae are there, quite simple. Cubes, I don't know whether you have covered in class 8 or not, okay, but the cubes form a very important part in class 9. So we saw a plus b the whole square, a minus b the whole square, then a plus 1 upon a the whole square, which is on the basis of a plus b the whole square. Then we saw a minus 1 upon a the whole square, which was on the basis of a minus b the whole square. Then we came to cube, a plus b the whole cube and a minus b the whole cube. Now we will just stretch it to fractions. Actually you have to just remember formula 5 and 6 as far as cubes are concerned. So formula 7 will be based on formula 5. If you understand 5, then you can derive 7 on the spot, and 8th one will be based on the 6th one. So last two formulae, a plus 1 upon a the whole cube, this will be a cube plus 1 upon a cube plus 1 upon a cube. Then what it is? 3ab. So what I had told you before, it is 3 into first term into second term. That's the way you remember. So now this will be 3 into a into 1 upon a into a plus b. But here there is no b. So this will be a plus 1 upon a. Here a and a will get cancelled. So the formula can be refined a bit. It could be a cube plus 1 upon a cube plus 3 into a plus 1 upon a. So comfortable? So a plus 1 upon a the whole cube will finally result in a cube plus 1 upon a cube plus 3 into a plus 1 upon a. But always make a habit of showing this step. You know, every time it is not necessary a and a will get cancelled. Okay. So this step is important, and then you show this, because instead of a, if it was 2a, and if and instead of 1 upon a it was 1 upon 7a, then things would change, right? It would be then 3 into 2a into 1 upon 7a, like that. Now we have to show you for a minus. In case you wish to take down all this formula, is simple, just pause the video, comfortably understand, take them down. Okay. Here now I will erase. A minus 1 upon a the whole cube. So this will be a cube minus 1 upon a cube minus 3ab, right? So it is 3 into first term into second term. So 3 into a into 1 upon a into a minus 1 upon a. Let's refine this further. This will be a cube minus 1 upon a cube minus 3 into a minus 1 upon a. This is done. Okay, so comfortable? So these are the 8 formulae. Actually, if you go to see, there are mainly 4. Others are based, the fraction ones are based on their master base. And then there is one factorization formula which will be useful here if you recollect. So this we will now erase. A square minus b square. This will not be a minus b the whole square, as we understand. A minus b the whole square is something different which you already know. This will be a plus b into a minus b. So example, if it is 4x square minus 9y square, suppose, and you wish to factorize it, this is based on factorization, but this will help you in expansions also. So I need to cover this. If you need 4x square minus 9y square, if you have to factorize, so this will be 2x the whole square minus 3y the whole square. So it will be 2x plus 3y into 2x minus 3y. So this will be used sometimes in between. Okay, comfortable with this? So now we have given you a good list of formulae. Learn only that. Don't learn the derivatives of it. You know, many books are giving like, reversed. These formulae what I have taught you are more than enough, and we will see now some typical problems involving squares and cubes all mixed. Then in the end we will come to trinomial square, which is very much there in our syllabus. That is a plus b plus c the whole square. That we will see it towards the end. So hope you are comfortable till here. Question 1. If 3x plus 4y is 14 and xy is 4, find the value of 9x square plus 16y square, 9x square minus 16y square, and 27x cube plus 64y cube. Now see, in the exam you will not get all such 3 subparts, because the sum would be for like 4 marks or in extreme case 5 marks. This will have to be set for 8 marks. But since this is an accelerated learning program, it is better I give you exposure to sum of 2 squares, difference of 2 squares, sum of 2 cubes. This way your mind will get churned and work better. At the same time, in one sum you will get a grip of like about 3 sums. Okay, so let us see now how do we go about the solution. Observe, we need 9x square plus 16y square. Okay, and 3x plus 4y is given and xy is given to us. So we will square both the sides. So 3x plus 4y the whole square is equaling 14 square. Fair enough. 3x plus 4y is 14. So 3x plus 4y the whole square is 14 square. Now 9x square, this is routine, 9x square plus 16y square. Since this is first sum, I will explain in detail. We square first term, that is 9x square. We square the second term, that is 16y square, like 4y into 4y and 3x into 3x. Then sign is going to be positive. Then we have first term into second term into 2. First term into second term into 2. So 3x into 4y into 2. So that is how much? 12xy into 2, that is 24xy. So plus 24xy is 14 square is how much? 196. And don't confuse between 13 square and 14 square. 13 square is 169, 14 square is 196. Okay, now what else can, now what we have to find? 9x square plus 16y square. So this has to be found out. So we will keep this as it is and substitute 24xy, 24 into 4, that is 196. Okay, because xy was given to be 4 and this is 24xy. Now we will treat this as an equation. We want 9x square plus 16y square. So let that be intact. 9x square plus 16y square is equaling 196 minus 24 into 4 is how much? 96. That 96 will go on that side. Okay, so this works out to be how much now? 196 minus 96. This is 96 only, 4 4s are 16, 4 2s are, yeah, that comes to 100. So we just double underline this answer to indicate that subpart 1 has been solved. So this is easy. So in 9th standard you can expect sums, with some coefficients. In 8th class you might have done sums like x plus y is 14. So where the coefficient is only 1, but now you will get some coefficients higher than 1 like this. Okay. So first part is complete. Now we have to see how to find 9x square minus 16y square. Be careful, you cannot square this and obtain. Even if this was 3x minus 4y the whole square, what will happen? When you square, it will become 9x square plus 16y square and you will get minus 24x5. That is 3x minus 4y the whole square. Okay. But we want 9x square minus 16y square minus. So here factorization will help you. Recall, what is 9x square minus 16y square? It will be, see, 9x square minus 16y square can be written as 3x the whole square minus 4y the whole square. This will be 3x plus 4y into 3x minus 4y. Okay with this? Now 3x plus 4y we already have. 3x minus 4y is something which we don't have. So only when we are able to find 3x minus 4y will we be able to tackle this part. So our first efforts should be in the direction to find 3x minus 4y. So what do we do? 3x minus 4y the whole square will be 9x square plus 16y square, first term into second term into 2. So that is 3x into 4y into 2. So that is how much? 24xy, negative 24xy. Okay. Now recollect that you had already found out 9x square plus 16y square, see, in the previous subpart. So put that to good use. So now this body will be 100 minus 24 into xy. Xy is 4. So this is 100 minus 96, that is 4. But what is 4? 3x minus 4y the whole square. So 3x minus 4y the whole square is 4. So 3x minus 4y is square root of 4. Right? 3x minus 4y the whole square is 4. So 3x minus 4y will be square root of 4, which is plus or minus 2. Take care of this negative possibility also. So now 3x minus 4y has been found out, but our target was something different. It was 9x square minus 16y square. So let's find out that now. Do not double underline this answer as this is not required. So keep in mind 3x minus 4y. I will keep this for your reference here. Now let us come to this. So 9x square minus 16y square will be 3x plus 4y into 3x minus 4y. Now what is 3x plus 4y? 14, already given. What is 3x minus 4y? We just now found out to be plus or minus 2. So we will write plus or minus 2. So 14 into 2 is one answer, or 14 into minus 2 is another answer. So the answer would be plus or minus 28. Comfortable? 14 into 2, 28. 14 into minus 2, minus 28. So answer is plus or minus 28. So this takes care of your second part. Now what is remaining is 26x cube plus 64y cube. We have to now find out 27x cube plus 64y cube. Now see, look at the base term. To get 27x cube plus 64y cube, which is your base term which you require? 3x plus 4y. And that if you cube it and then substitute and all, you will get this. So 3x plus 4y is our base term required. Do we have that? Oh yes, it is directly given. So it will be now 3x plus 4y, the whole cube, will equal 14 cube. Okay. Open up this, because 3x plus 4y is 14. So 3x plus 4y, the whole cube, will be 14 cube. How much is 14 cube? Please calculate and keep it ready. Of course, you won't get such big numbers in the exam, but now please keep it ready. Okay. Now let's work out this. This will be 27x cube plus 64y cube. You remember this? A plus b the whole cube. Now the formula for a plus b the whole cube is coming. So it is a cube plus b cube. So instead of a it is 3x, and instead of b it is 4y. So 27x cube plus 64y cube. Then first term into second term, that is plus 3ab. You recollect that? So it is plus 3ab. So it won't be plus 3xy. It will be plus 3 times of first term into second term. When it is a and b, we write 3ab. But now there is no a and b. It is 3x and it is 4y. So it is plus 3 into 3x into 4y. Yeah? This is of paramount importance. Most of the students write here plus 3xy, which is naturally wrong. Into 3x plus 4y. 14 cube. How much is 14 cube? 2744. Okay. Now what is to be found out? 27x cube plus 64y cube. So 27x cube plus 64y cube will remain as it is. 3 into 3 9, 9 into 4 36, 36 xy. But what is xy? 4. So 36 into 4. Okay, 3 into 3 9, 9 into 4 36, 36 xy. Xy is 4, so 36 into 4 into 3x plus 4y. 3x plus 4y is 14. Now this you have to multiply, a big thing, and keep it ready. 2744. Okay, we are nearing the completion. So 36 into 4 into 14 is what you have to multiply. And tell me. So 27x cube plus 64y cube plus how much? 2016 is equaling 2744. Now we have to just find out this 27x cube plus 64y cube. So 27x cube plus 64y cube will be 2744 minus 2016. Okay, now this is not a difficult subtraction. How much this works out to be? Let us do it. 2744 minus 2016. So this is 8 and then 2, 728. So finally 27x cube plus 64y cube turns out to be 728. And this completes your sum. So we took care of squares, sum of two squares, difference of two squares, and then even your cubes. So comfortable with question 1? Question 2. If twice of x square plus 1 is equaling 5x, find all these things: x minus 1 upon x, x plus 1 upon x, x cube minus 1 upon x cube, and x raised to 4 plus 1 upon x raised to 4. So let us see. Here the question is not given in the standard form, like normally they give you a plus b ka value or a plus 1 upon a's value. Here it is put in a very different way. So we will little bit simplify. It's a typical sum. So 2x square plus 2 minus 5x will equal 0, isn't it? I have just opened the bracket. 2x square plus 2, 5x you take on this side, so is equaling 0. Now what do we want? We want x minus 1 upon x, the value. So let us see how do we go about it. You collect the x terms together first and keep the number on the other side. Okay, in such kind of sums, you keep all the x components together and the number on the other side, because once you look at the question, one can judge how it will go about. So this is 2x square minus 5x is equaling minus 2. Okay. Now we will divide each and every term by x, or wait, in this case only we could have done that. Later on we will transpose it. Okay. So what we will do, let's first open up the brackets, which we have done. 2x square plus 2 minus 5x is 0. Let it remain like that. Now we want x minus 1 upon x. So what we do, we divide each and every term by x. So here we divide this term by x, this term by x, this term by x, and this term by x. You can show this step. It is good to show this step. Now here you will have 2x square upon x will be what? 2x plus 2 upon x, so it will remain like that only. X and x will nicely get cancelled here. Minus 5 is equaling 0 upon x. 0 upon x is 0. Okay, see now something we are coming closer and closer. We want x minus 1 upon x. Here 2 is coming, here also 2 is coming. So we can take 2 as a common factor. So 2 we can take common, we will get x plus 1 upon x, isn't it? 2 into x, 2x. And here 2 is already there, so 1 will come, 1 upon x. So now if you open this bracket, you should get back this step, and you are getting it. So we are correct. Minus 5 is equaling 0. So now we will take minus 5 on that side. So twice of x plus 1 upon x is equaling 5. Minus 5 will come here. What is, now we will, from this we will try to extract x plus 1 upon x, that is 5 upon 2. Right, now the sum comes in the familiar form. So, but they have asked here x minus 1 upon x. So that is not difficult. Once you get the sum in this standard form, x plus 1 upon x, then now it is easy. So this much of work we had to do. So it's a typical problem. Keep this trick in mind. This sum can come in a diluted form. How? A square minus 5a plus 1 equaling 0. I mean, I am just talking about the diluted version of this sum. A square minus 5a plus 1 equaling 0. Find so and so, so and so, so and so. So there also what you do, you divide each and every term by a, and that will come out easier. Here we had to do factorization and all that. There it may work, it will come directly. Okay, so keep that sum in mind. Now, x plus 1 upon x has been found out. We need to find x minus 1 upon x. So how do we do? Given plus, find out minus. X plus 1 upon x given, find x minus 1 upon x. So there are some advanced identities also which I will tell you in the end after this sum. If you wish, you can use that. Otherwise you can go by the little lengthier but the conventional technique. You square this first. So this will be x plus 1 upon x the whole square is equaling 5 upon 2 the whole square. This will come now x square plus 1 upon x square. Now the routine formula I am applying, a plus b the whole square. First term into second term into 2. So that would be plus 2 is equaling 25 upon 4. So x square plus 1 upon x square will be 25 upon 4 minus 2. Take LCM 8, 17. This works out to be 17 upon 4. This is the value of x square plus 1 upon x square, which is not asked. Is it asked here? No. But we will require it somewhere. And x plus 1 upon x was asked in the second part. So this part is done now. Sometimes you may get the second part first. At times it happens. Okay. Now revisiting this, we want x minus 1 upon x. So let us see, x minus 1 upon x the whole square we will do. This will be x square plus 1 upon x square, first term into second term into 2, so that come minus 2. Now see, x square plus 1 upon x square we know, we found it out, 17 upon 4. So this is 17 upon 4 minus 2. So 8, take the LCM. This comes out to be 9 upon 4. Whose value is this? X minus 1 upon x the whole square. So now x minus 1 upon x will be square root of 9 upon 4, which will be plus or minus 3 by 2. Okay. So x minus 1 upon x is also over now. X plus 1 upon x is also done. So remember, they are typical sums. Given plus, find minus, like that. Now we have to come to the last two subparts and we are done with this question. So keep this in mind, x square plus 1 upon x square was 17 upon 4. I will keep it because it will be required for x raised to 4. No? So we will just erase this portion. We will just draw a line here. Okay. Now what is our next target? So these two are done. X cube minus 1 upon x cube. So what is the base term here now? X minus 1 upon x is the base term. So we will write x minus 1 upon x the whole cube. And do we know x minus 1 upon x? Yeah, okay, this we are aware of. Fine. So this will be x cube minus 1 upon x cube minus 3ab, 3 into first term into second term. So 3 into x into 1 upon x. So it will get cancelled into x minus 1 upon x. Now what will happen is, you will have to show with both the possibilities in the exam. But now what I am doing is, I am considering x minus 1 upon x as 3 by 2 and showing you that you can repeat the same procedure with the other value x minus x as minus 3 by 2. Same procedure with the negative value that you will do on your own. Okay, now this will be, wait, x minus 1 upon x is 3 by 2. So it is 3 by 2 the whole cube. This is what we have to find it out. So this will remain as it is, minus 3 into x minus 1 upon x. What is x minus 1 upon x? 3 by 2. Okay, this is done. Fine. And we will have to erase this. Keep in mind that this is 17 upon 4. Somewhere I will write. Okay. Open up the brackets. 27 upon 8 is x cube minus 1 upon x cube minus 9 upon 2. Now this we have to find it out. So keep it there, this you transpose. So 27 upon 8 plus 9 by 2 is equaling x cube minus 1 upon x cube. So now can we take LCM? Yes, so this will equal what now finally? LCM is 8. So this is a 27, 8 upon 2, 4, 4 into 9, 36. How much this turns out to be? This is how much? 7 plus 6, 13, 63. 63 upon 8, and this is in the simplest form. So the value of x cube minus 1 upon x cube under the given conditions turns out to be 63 upon 8. So subpart 3 is now done. See, the exam you will not get so many subparts, okay, for like a 3 or 4 marks question, but here we are taking it all together. So this if you can do and handle, the simpler versions of these sums you can easily handle. Now we are left with only x raised to 4 plus 1 upon x raised to 4. Okay, now what is a base term? See, if you take the base term as x plus 1 upon x, it will be a problem, because then you will have to do x plus 1 upon x the whole raised to 4, which we are not aware of, though there are advanced formulae for the same, but they are not in our curriculum, so we are not going to use them. So what we will do, we will take x square plus 1 upon x square as the base term. X square plus 1 upon x square we will take as our base term, and this value was how much? 17 upon 4, because see this if I square it further, then you will get x raised to 4 plus 1 upon x raised to 4, no? So this is what we had found out already. Now we will square both the sides. So if we square both the sides, it will come like this. Now just simply open up the brackets, x raised to 4 plus 1 upon x raised to 4, first term into second term into 2. So x square and 1 upon x square will get cancelled. So you will have plus 2 is equaling 289 upon 16. X raised to 4 plus 1 upon x raised to 4, what you have to do is simply transpose, plus 2 will go there. So you will have 289 minus 32, okay. So that comes to how much? A quick calculation, 257 upon 16. Can it be simplified further with 4, 7? No, and this is the best form. So x raised to 4 plus 1 upon x raised to 4 under the given conditions works out to be 257 divided by 16. And this completes your question number 2. Question 3. If 5x square plus 1 the whole divided by x equaling 6, find the value of 25x square minus 1 upon x square and 250x cube plus 2 upon x cube. See, all the sums which we have covered so far, including this, these are heavy concentrated sums. So either you can get this in the exam with just one subpart, or you will get diluted versions of this. But if you can understand these sums and if you practice these properly with the reasoning, you will be able to solve practically all the sums which are there in the regular textbooks, which are diluted versions of these. Okay. Now observe, again it is not given in a proper form, normally we used to be given x plus 1 upon x or something like that, a plus b. Here they have given 5x square plus 1 the whole divided by x equaling 6. So what we do? We do double division. See, we can give x to this term, we can give x to this term, yes. If it was multiplication sign, then x can be given to one of the two, not both. But here it is plus, so if it is plus or minus, and if it is full thing divided by, then x can be given to this term, x can be given to this term. So it will be 5x square upon x plus 1 upon x is 6. Now this would be 5x plus 1 upon x is 6. Now it has come in our familiar form. We wish to find 25x square minus 1 upon x square. Okay. Be careful, it is difference, it is not plus. So if you square this, you will not get 25x square minus 1 upon x square. So let's analyze first. 25x square minus 1 upon x square is difference of two squares. So here factorization will come into the picture. This will be clearly 5x plus 1 upon x into 5x minus 1 upon x. We will have to simply multiply the two. Now 5x plus 1 upon x, we know it is 6, but we do not know 5x minus 1 upon x. So first we will have to find 5x minus 1 upon x. Okay, now how do we find 5x minus 1 upon x? Recall, we had a similar situation in the previous sum. Given plus, find minus. Like x plus 1 upon x was given and we had to find x minus 1 upon x. Okay, so now here it is something like that. So first we will square both the sides. From there we will get 25x square plus 1 upon x square, and from then we can extract 5x minus 1 upon x. So now let's square both the sides here. 5x plus 1 upon x the whole square is equaling 6 square. So routine opening up of brackets, 25x square plus 1 upon x square, first term into second term into 2. Take care now. First term into second term into 2. So x and x will get cancelled. 5 into 2, 10. Positive into positive is positive. So plus 10 is equaling 36. Okay. Now what we have to find? 25x square plus 1 upon x square. So in fact, this also could have been one of the subparts. Okay, but anyway here it is not asked. So 25x square plus 1 upon x square will be 36 minus 10, that is 26. So this we have now got it. What is our target before we find that subpart 1? 5x minus 1 upon x. So now we will do 5x minus 1 upon x the whole square is equaling 25x square plus 1 upon x square. First term into second term into 2. So 5x into 1 upon x into 2, that is 10. And positive into negative is negative. So minus 10. Okay, now 25x square plus 1 upon x square, we just found it out. So that is 26, and this is minus 10. This works out to be 16. So 5x minus 1 upon x will be square root of 16, which is plus or minus 4. Take care of it. Plus or minus 4. So we have now found out 5x minus 1 upon x. We proceed on to finding subpart 1. Keep this value in mind. Okay, now 25x square minus 1 upon x square will be 5x plus 1 upon x, factorization this is, difference of two squares, into 5x minus 1 upon x. Now 5x plus 1 upon x, we worked it out in the very beginning, that was 6, and 5x minus 1 upon x, we just now worked it out, it was plus or minus 4. So two possibilities, plus or minus 4. So now 6 into 4 is 24, 6 into minus 4 is minus 24. So this would be plus or minus 24. So 25x square minus 1 upon x square, the value has turned out to be plus or minus 24. Now we have to look at this part. So this you are comfortable with? Okay. Here if you see, it is nice cube, but there is a problem. This is 250. It is not any numbers cube, you know. So there will be a problem. So even if you do 5x plus 1 upon x the whole cube, you will get 125x cube and all. So and we can't find cube root of 250 like properly. That means there is some catch in the problem. So you will have to just observe this sum. You will have to first remove 2 common. Okay, so keep these tricks in mind. So 250x cube plus 2 upon x cube. We can take 2 outside. We will get 125x cube plus 1 upon x cube. This is nice now. So this portion, this body can be easily found out, and you multiply by 2 and you will get the value of the required. So first what we will do is we will try to find out the value of 125x cube plus 1 upon x cube. So as we discussed, we will have to find out 125x cube plus 1 upon x cube first and then multiply by 2 to get this. Now 125x cube plus 1 upon x cube find करने के लिए which is the base term required? 5x plus 1 upon x, which we already had in the beginning. So 5x plus 1 upon x was 6, you know, in the beginning if you recall. Now we will cube both the sides. This will be 125x cube plus 1 upon x cube. This is a plus b the whole cube, plus is 3ab. So it is 3 into first term into second term. Don't write always 3, sometimes different things can also come, na? 3ab, okay, 3 into first term into second term into a plus b. So that is 5x plus 1 upon x. This is the expansion of this. It is equaling 216. 6 cube is 216. So 125x cube plus 1 upon x cube. Now this will get cancelled. 3 into 5, 15. 5x plus 1 upon x can be substituted. That is 6. 5x plus 1 upon x is 6 is equaling 216. So this will be 125x cube plus 1 upon x cube plus 90 is equaling 216. So 125x cube plus 1 upon x cube will be 216 minus 90. Simply transpose 90 there because we want to find this value. How much this works out to be? If it was 100, then it would be 116. Now it is 90. So it will be 126. This does not complete your sum. Mind you, our target is this. Now 250 x cube plus 2 upon x cube will be twice of 125 x cube plus 1 upon x cube. We have taken 2 common because in the beginning we realized that this we are not getting any base term. If I cube in such a way that you get 250 and all, you know, it's not a perfect cube. So we thought of factorizing it. Okay, this is 2 and 125 x cube plus 1 upon x cube, we just now found it out, 126. So 2 into 126. How much this comes to? 252. And this completes your question number 3. Hope you enjoyed this. There are 3 or 4 more questions and then you are done with this topic. Question 4. If 8a cube plus b cube is minus 9, 2a plus b is minus 3, find the value of ab. 8a cube minus b cube and 16a raised to 4 plus b raised to 4. Many subparts are there. Let us see. Now see, we need to find ab here and we are given 2a plus b and we are given this cubes also. So what would be the most obvious thing? To cube both the sides here, not to cube here. This is already cube. This if you cube, it will become 5 and 2 a raised to 6 and plus b raised to 6 and so on. Right. So that wouldn't be appropriate. We will have to take 2a plus b the whole cube will equal minus 3 the whole cube. So now routine x plus y the whole cube bracket opening. This will be 8a cube plus b cube plus 3ab, 3 into first term into second term. So it will be 3 into 2a into b, mind you. It won't be 3ab. When 3ab comes, when it was a plus b the whole cube. Now a is not a, it is 2a and this is b. So it is 3 into first term into second term. That way you remember, into 2a plus b is equaling minus 27. Now 8a cube plus b cube is given to us minus 9. So this would be minus 9. 3 into 2 6. This is 6ab into 2a plus b is equaling minus 27. So this is minus 9. Now let's substitute. ab is what we have to find out. So we will have to keep it like that, 6ab. 2a plus b can be substituted. Observe there, 2a plus b is minus 3. Put this bracket, 6ab into minus 3. If you do not put the brackets, the meaning will change. It will become 6ab minus 3 equaling minus 27. Okay. Now this we will erase. Now it is simple equation. So it is minus 9 minus 18ab is equaling minus 27. Okay. So minus 18ab is equaling minus 27 plus 9. How much? That is minus 18. So minus minus balances. So AB will be 1. Simple. I can just bring minus 18 down. So AB will be 1. So this part is now over. So we should double underline this, indicating that one of the subparts has been successfully solved. Okay. So now remember, AB is 1, it may help us in some other sum. So I am just writing here AB is 1. It was not given, we found it out. Okay. Next subpart, find 8a cube minus b cube. This we have to ponder. Wait. 8a cube minus b cube. So which will be the base term which is required? 2a minus b. So when I do 2a minus b the whole cube, this will appear in its expansion. But 2a minus b is not given. What is given is 2a plus b. So we cannot directly find now 8a cube minus b cube. So what to do? So first we will find 2a minus b. Okay. How do we find? Recollect the previous sums. We are on sum number 4. We have done such situations. Not this sum, but such situations. Given plus, find minus. Kuch yaad aaya? So first we will have to square both the sides. We will get 4a square plus b square ka value. From there we will find 2a minus b. And once we find that, we can find this by routine formula. So now let us first do like this. So 2a plus b the whole square is minus 3 the whole square. 4a square plus b square, then first term into second term into 2 is a plus b the whole square. So that will be how much? Plus 4ab is equaling 9. Now 4a square plus b square plus 4ab. ab was 1. So we can substitute. So 4a square plus b square will be 9 minus 4, that is 5. So now we have obtained the value of 4a square plus b square. From this we will extract 2a minus b. Why are we doing so much of work? Because we need to find 8a cube minus b cube, for which the base term is 2a minus b, and 2a minus b is not given. So 2a minus b the whole square now we will do. 4a square plus b square, first term into second term into 2. So minus 4ab. Now 4a square plus b square is how much? 5. Minus 4 into ab. ab was how much, you recollect? 1. So that is 5 minus 4, that is 1. But this is 2a minus b the whole square. So 2a minus b will be square root of 1, which is plus or minus 1. Having found out that, now it is possible to find the value of 8a cube minus b cube. We have got our base term. Now see, there are two possible values. 2a minus b is plus or minus 1. So I will show you for the positive possibility. Same process you can repeat with the negative possibility. So you will get two different answers for 8a cube minus b cube. So I will show you one of them. So now 2a minus b the whole cube. What is 2a minus b? 1 now. I am taking the value as 1. Next part you can take it as minus 1 and work out it again. This will be 1 cube, isn't it? If 2a minus b is 1, 2a minus b the whole cube will be 1 cube. You use your formula now. 8a cube minus b cube minus 3ab, So that is 3 into first term into second term into 2a minus b is equaling 1. Now 8a cube minus b cube minus 6ab into 2a minus b is 1. This is what we want to find out. So keep it as it is. So 8a cube minus b cube, substitute, ab was 1 if you recall, and 2a minus b is also 1, is equaling 1. Okay, so 8a cube minus b cube, this is 6 into 1 into 1, so that is minus 6, minus 6 gets transposed on that side, it becomes 1 plus 6, that is 7. So we have found the value of 8a cube minus b cube as 7, but there is one more answer to it, because 2a minus b was also minus 1. So you will have to rework out this, and you will get one more answer for 8a cube minus b cube, which you can handle. So we have finished this part now. Now remains your last part, question subpart 3. Okay. Now for this, which will be our base term? If you take 4a plus b as your base term, the whole raised to 4, no, 2a plus b, the whole raised to 4 if you take, you will feel you will get this, but then how do we know the expansion of x plus y the whole raised to 4? That we are not aware of in class 9. So what we do, we take, remember this similar situation came in one of the previous sums. So we took 4a square plus b square as our base term. So we will do like this now, 4a square plus b square was 5. That is what we worked out somewhere some time back. Now this we will use as our base term for higher powers. So this was already found out previously. Now you square both the sides. So 4a square plus b square the whole square will be 5 square. So this will be 16a raised to 4 plus b raised to 4. Then first term into second term into 2. So that would be 8a square b square is equaling 25. Now this is what we want. So keep this as it is, 16a raised to 4 plus b raised to 4. This you can write it as ab the whole square. A square b square we can write it as ab the whole square is equaling 25. Okay, this will be 16 a raised to 4 plus b raised to 4 plus 8. What was ab? We found out 1. So 1 square is 25. So 16 a raised to 4 plus b raised to 4 plus 8. 1 square is 1. Okay, that is 25. Now 16 a raised to 4 plus b raised to 4 will be 25 minus 8, that is 17. And this completes with your this. So like your one sum is equivalent to 3 sums here. It is fully churned. Very difficult to find such questions in any standard book. Okay, so take this question seriously and you will get a very good grip on this topic. Now question 4 is done. We have 3 more questions remaining. Question 5. If a plus 1 upon a the whole square is 4, find the value of a cube minus 1 upon a cube. Now be careful, here it is not a square plus 1 upon a square, the routine what is to be given to you. It is a plus 1 upon a the whole square is 4. So we have to find the value of a cube minus 1 upon a cube. How do we go about? See, a plus 1 upon a the whole square is 4. So a plus 1 upon a will be square root of 4, which is plus or minus 2. So there are two values now. A plus 1 upon a can be 2 or a plus 1 upon a can be minus 2. So I will show you with one possibility. Similarly, you can work out with the other possibility also. So there will be 2 answers for a cube minus 1 upon a cube. Now see what will happen in the exam. Sometimes they may give you here square root of 3 or square root of 7. Then don't consider 2 possibilities because it is already specified square root of 3. Suppose instead of 4 it was square root of 3 or something like that, or it was say it was square root of 3. So in that case you just go with the positive possibility. But here when we take the square root, we have to show both the possibilities. So a plus 1 upon a works out to be plus or minus 2. So now I am considering a plus 1 upon a as 2 and working out the sum. You will have to work out with the other possibility also, that is a minus 1 upon a plus 1 upon a as minus 2 on similar lines. Okay, what do we want? Find the value of a cube minus 1 upon a cube. See, to get a cube minus 1 upon a cube, the base term required is a minus 1 upon a. But we do not have that. We have a plus 1 upon a. So first we have to find a minus 1 upon a. So something you remember? Given plus, find minus. So what do we do? First we will have to square both the sides. Find a square plus 1 upon a square and then extract a minus 1 upon a from it. So now this will be a plus 1 upon a the whole square, that is 4. So we will open up this brackets. A square plus 1 upon a square, first term into second term into 2, so that is plus 2 is equaling 4. So a square plus 1 upon a square is equaling 4 minus 2, that is 2. Okay. So now we have found a square plus 1 upon a square. Though it was not asked explicitly, now we will do a minus 1 upon a the whole square. Why are we doing this? So that we can get a minus 1 upon a, and then with that help we can find a cube minus 1 upon a cube. So a minus 1 upon a the whole square will be a square plus 1 upon a square, first term into second term into 2, so that gets cancelled, minus 2. Now a square plus 1 upon a square is how much? 2. This whole thing, a square plus 1 upon a square, we worked out to be 2 some time back. 2 minus 2, 0. So it is, so therefore a minus 1 upon a the whole square has now turned out to be 0. Nice number, no problem. So a minus 1 upon a will be square root of 0, which is 0. As you are aware, 0 is a non-positive, non-negative integer. Now what is our final target? A cube minus 1 upon a cube. So what to do? Cube both the sides. So this will be now a minus 1 upon a, the whole cube is equaling 0 cube. Open up this. This will be a cube minus 1 upon a cube minus 3ab. So it is 3 into a into 1 upon a into a minus 1 upon a is equaling 0. This is what we have to find out. A cube minus 1 upon a cube. So you keep it like that, a cube minus 1 upon a cube. This will get cancelled. Minus 3 into a minus 1 upon a. A minus 1 upon a was how much? 0. So we have to substitute that, is equaling 0. So a cube minus 1 upon a cube. 3 into 0, 0. 0 will go on that side. So a cube minus 1 upon a cube has now turned out to be 0. Don't think you are wrong, it is correct. Okay. So we have successfully finished this sum. Just double underline your answer. This completes with your question 5. Question 6. If 3a plus 5b plus 4c equaling 0, show that 27a cube plus 125b cube plus 64c cube is 180 ABC. Okay, a different kind of a sum. Now see, here a trinomial is given, 3a plus 5b plus 4c, and they want cubes also. Now we do not have any formula for a plus b plus c the whole cube. I mean, we are not aware of it. That is too advanced for standard 9th. So then how to go about it? See, you know x plus y the whole cube. So let's manipulate this. 3a plus 5b plus 4c is equaling 0. This is given. So see, now how do we play with this? 3a plus 5b plus 4c is 0. This is called conditional proof. Like if this is 0, then prove this under the given conditions. So what we do? This is given. So 3a plus 5b will equal minus 4c. Anything you can take it on that side. Any one term is not necessarily this term. If 3a plus 5b plus 4c is 0, 3a plus 5b will be minus 4c. Okay. Now you cube both the sides. If you cube both the sides, now things will be okay. Now we can cube both the sides because it's a simple binomial. So 3a plus 5b the whole cube is equaling minus 4c the whole cube. This is now like your a plus b the whole cube. So it is 27a cube plus 125b cube. Then what will come? Remember, 3ab. So it is 3 into first term into second term. It is not always 3ab. So it is 3 into 3a into 5b into 3a plus 5b. This will equal how much? Minus 4c the whole cube. That is minus 64c cube. Okay. So this now works out to be 27a cube plus 125b cube plus 45ab into 3a plus 5b is equaling minus 64c cube. Okay, what we have done is I have just multiplied 3 into 3, 9, 9 into 5, 45. Okay, now we are nearing the completion. Now we will have to substitute. This is 27a cube plus 125b cube plus 45ab bracket into 3a plus 5b. What is 3a plus 5b now? Minus 4c, because 3a plus 5b plus 4c is 0. So 3a plus 5b will be minus 4c. So this will come into minus 4c is equaling minus 64c cube. Beware, you will have to put the brackets because it is multiplication. If you do not put the bracket and if you write minus 4c, the meaning will totally change. Okay, this works out to be now 27a cube plus 125b cube, 45ab into minus 4c. So 45 into 4, 180, and positive into negative, negative. So minus 180 abc is equaling minus 64c cube. This is what we have got. Let us see what we want. We want 27a cube, that is there. This is also there. We want 180 abc on that side. Fine, we can now simply transpose, and this we can take it on this side as per the need of the question. So 27a cube plus 125b cube minus 64c cube will come on this side. It becomes 64c cube minus 180 abc will go on that side. So, and exactly that is what we wanted, hence proved. So here we cannot follow LHS RHS technique. Okay, fine with this? So these kind of applications, sums can come in the exam. They are not difficult. Only the first step you had to know that you keep two terms here and put one term there. Cube both the sides because we want cubes, and then manipulate, simplify, substitute, and you will automatically get the desired. So this completes with your question 6. Okay, before we come to the final question, you need to know this new concept, and it is pretty important. This is a plus b plus c the whole square, not whole cube, whole square, trinomial square. How do we go about it? It's pretty manageable, simple. A plus b plus c the whole square. You square first term, you will get a square. Then you square second term plus b square. Then you square third term plus c square. Sign will always be positive because we are squaring it. Now, first term into second term into 2. Now, don't learn this as 2ab and all that. No. First term into second term into 2. Sign you adjust logically. Like if you are multiplying these two terms, positive into positive is positive. So, this will be plus 2ab. Second term into third term into 2. Second term into third term into 2, adjust the signs logically. So this will be plus 2bc. Third term into first term into 2. So c into a into 2 plus 2ca, because positive into positive is positive. So plus 2ca. This can be refined as, this can be further refined as a square plus b square plus c square plus 2 we can take common. It will be AB plus BC plus CA. Comfortable? See, don't remember this finished product. Remember this, understand this. From this you derive here. Now let us take a little modified version. A plus B minus C the whole square. First you try without looking. You can pause the video and try this. Okay. And then look here. Square first term, A square. Square second term plus B square. Square third term plus C square. Whenever you square, terms are positive, so no problem of sign. Now what? First term into second term into 2. Sign to be adjusted logically, so positive into positive is positive. So plus 2AB. Second term into third term into 2. So B into C into 2, that is 2BC, and positive into negative is negative. So minus 2BC. Then what we had told you? Third term into first term into 2. So C into A into 2, that is 2CA, and negative into positive is negative. So minus 2CA. Let's refine this. A square plus B square plus C square plus 2 we can take common. Now we will get AB minus BC minus CA. Simple. Similarly, you on your own can now design the formula for A minus B minus C the whole square. Anyways, let me do it. A minus B minus C the whole square. Square first term, A square. Square second term plus B square. Square third term, so it will be positive whenever you square. Now first term into second term into 2. Sign to be adjusted logically. So A into B into 2, that is 2AB. Positive into negative is negative. So minus 2AB. Similarly proceeding, second term into third term into 2, both of them are negative. So negative into negative is positive, that is plus 2BC. Third term into first term into 2. So negative into positive is positive. No, negative into positive is negative. So minus 2CA. We'll have to refine this. Okay, this I will erase. Clutter goes away. Now this will finally refine to be A square plus B square plus C square. Minus 2 we can take common. It will be AB. Now be careful, this will be minus BC. Because minus 2 we have taken common, and minus into minus is plus. That is why. And this will be plus CA. Done. So finally A minus B minus C the whole square results in A square plus B square plus C square minus twice of this. So these three we have done, and we will see one typical question based on this, and you are done with this topic. Question 7 and the final question for this topic. If 2x minus y minus z equaling 0 and 4x square plus y square plus z square is equaling 6. Okay, if 2x minus y minus z equaling 0 and 4x square plus y square plus z square equaling 6, find the value of this. So this is a clear-cut case of a trinomial square. So how do we go about? What we will do? Use your previous knowledge, what we just taught you, 2x minus y minus z the whole square. Now open it up. What we have told you? Square first term, so that would be 4x square. Square second term plus y square. Square third term plus z square. Signs will be positive because we are squaring, no problem. Then first term into second term into 2. First term into second term into 2. So 2x into y into 2, 4xy. Positive into negative is negative. So minus 4xy. Then second term into third term into 2. So y into z into 2. 2yz, adjust the sign logically. Negative into negative is positive. So plus 2yz. Third term into first term into 2. So z into 2x, that is 2xz into 2, that is minus 4xz, because negative into positive is negative. Now this value is given to us, 2x minus y minus z, the whole, this is how much? 0. So simply substitute. So 0 square will be, and notice even this value is given to us, 4x square plus y square plus z square is 6. So instead of this we write 6. Now from these three terms we can remove minus 2 common. So minus 2 we will remove common. We will get here 2xy minus yz plus 2xz, isn't it? See, minus 2 if you remove common, you will get 2xy naturally, because when I multiply this we need minus 4xy, and this 2 is already here, but they want positive, so we will have to take negative because already one negative is outside. So that's elementary factorization. 0 square is 0. Now some of you may make the mistake of writing 6 minus 2 as 4. That it can't work, is absurd. It is 6 minus twice of this. So this is like a single entity. It's like, in case if you don't understand this, it's like saying 6 minus 2y. Would you do 6 minus 2? No. So it is something similar. Okay. We can transpose this now here only. We will save on the steps. 6, 0 square is 0. 6 will come here. So that becomes minus 6 is equaling minus twice of 2xy minus yz plus 2xz. And see, that is what we wanted. We wanted 2xy minus yz plus 2xz. Now minus 2 will come down here, it will become division because this is multiplication. So minus 6 upon minus 2 will give the value of 2xy minus yz plus 2xz. Okay. Minus 6 upon minus 2, 3. So now 3 will equal 2xy minus yz plus 2xz. So this completes with your problem, and we can write this here first because it's very odd to write 3 is equaling y. It is always better to write y is equaling 3. So 2xy minus yz plus 2xz finally results in 3 under the given conditions, and this completes with your topic. And as I had told you in beginning, I will just give you 2 advanced identities which if you wish you could use it, okay, but they are not really required here, but we can use that. So just 2 more minutes and we are done with this. Those were like this, advanced identities. A plus b the whole square plus a minus b the whole square is twice of a square plus b square. So this is like, very useful if a plus b is given and a minus b is given and you wish to find a square plus b square. So directly you will get it, rather than finding a square plus, squaring this and from that you extract this. You can use this directly also if you are comfortable. Then you have a plus b the whole square minus a minus b the whole square is 4ab. It is 4 into first term into second term, but be very careful while using these identities. If it is not a and b, if it is 2x plus 3y, and here also if it is 2x minus 3y, then this won't be 4ab, it will be 4 into 2x into 3y. So you have to use the observation pattern how it is. Because this is a and b here, it is 4ab, and the square is very essential. If you do not put this whole square, and if you do a plus b minus of a minus b, how can it result in 4ab? So, and even if you forget this, actually you can derive it on the spot. You open up this bracket, add, you will get this. So even if you forget, or if you are confused between whether 4ab should come or this should come, you simply open the brackets, simplify and see what you get it. So it is not some formula which big complex formula which you can't like think for it. I mean, you just do simple algebra and you will get it. Okay with this? Done. So this completes with the topic of expansions. Hope you enjoyed it. Thank you so much.